Hey guys, today we're going to do kind of a review of all of our transformation stuff we did at the end of last week. We'll do a couple new examples as well, but just kind of reviewing all the transformations. Okay, so for our transformations, remember it does have to be in vertex form. Have to have an A, have to have an H, and have to have a K. Okay, so just to review what each of those do here again, remember the A controls two things. Okay, it controls how wide or narrow the graph is. Okay, and then it also is going to control which direction it goes, so whether it opens up or down. Okay, so remember that's the two things that the A can control. Okay, the H, okay, which is always inside the parentheses, will always control the left or right. Okay, so again, whether we're shifting left or right. Okay, and then the K will always do our ups and downs. Okay, so again, just a quick reminder, that's what you did on Thursday and Friday of last week, was kind of play around with those transformations a little bit. We'll kind of do the same thing here. We're going to start off similar to an example we had last time, just to practice it a little bit more. And then we'll get into a few new ones that we're going to have as well here. Alright, so these are the first two we're going to look at here. Again, very, very similar to ones that you did before, like I said, but we'll go through them. Okay, so in this problem you have an A and you have a K. There's no H because there's no parentheses. Okay, because the A is positive, it tells me that it's going to open up. Because the absolute value of 3 is 3, which is greater than 1, that tells me it's going to be narrow. And because the K is a negative 2, that tells me that it's going to be shifted down 2. Okay, so that would be the three transformations that that one would have. Okay, for B, okay, kind of the same type of idea. This would be your A, this would be your H, and this would be your K. Because the A is negative this time, it is going to open down. Absolute value of negative 1/2 is 1/2, okay, which is less than 1, so that tells me it's going to get wider. A negative 2 is my H. It's inside the parentheses. Anytime it's negative, it says it's going to move to the right. And then our K is positive 4, so it's moving up 4. Okay, so again, you did some of those on Friday, just a quick review of those type of problems. So the next problem we have then is we're actually going to flip that around. So we're going to give you the words and then you want to change it into the equation. Okay, so for the first one you guys have, it says it opens down, shifts left 3 and up 2. Okay, so they're always going to be y equals or fx equals, whichever one you prefer, doesn't matter to me. Okay, now you're going to have the a on the outside, then you're going to have an x, a squared, and then we'll fill in the rest of it. Remember, the a goes here, the h goes here, and the k goes here. So this one just opens down. It doesn't say anything about narrow or wide. Okay, so that just means that it will be a negative. Okay, again, technically a -1 because that doesn't make the graph narrow or wide. Okay, next it says it's shifted left 3. Okay, left 3 means I need a positive 3 as my h. And then it says it's shifted up 2. That means my k would be a positive 2. So this would be the function we would want for the first one. Okay, for B, it says it's narrowed by a factor of 3, shifted right 4 and down 3. Okay, it doesn't say anything about it flipping over, so we'll just assume then it opens up unless they tell us differently. Okay, so again, kind of the same setup here, and then we'll fill in our numbers. Okay, it says it's narrow by 3, so that means I want my A to be a positive 3 because it didn't say anything about it being downward. Okay, it tells me I have shifted right 4, that would mean a minus 4. And it says it's shifted down 3, which would then be a minus 3 for the K. Okay, so we can do it both ways. Either given the words, we can write the function, or given the function, we can write the words. Okay, the next type of example we have is when you're actually given a graph. Okay, so for the graph ones, I'll kind of do the best I can here to graph these real quick. Okay, so for the first one I gave you, and again, it looks a lot better on yours than it does mine, but we'll kind of get the idea here. Kind of goes up like that. Okay, so again, the three things we need to find are the A, the H, and the K. Okay, so to find the A, what you have to do is first tell what direction it's opening. This one's opening up, so it's going to be a positive A. And then to figure out, and again, it's much easier to see on your graph than it is on mine, but to figure out what the A is, you always go over one spot, and then you see how much it went up. Okay, so on this one, you'll notice that when you go over 1, it also goes up 1. That tells me that my A is just going to be a positive 1. If you gone over 1, if you would have gone up 2, then your A would be 2. Okay, when you went over 1, if you only went up a half, then your A would be a half. Okay, so you always go over 1 and then just see how far you went up. Okay, and that will tell you what your A is going to be. For your H, that's how much we went left or right. We always go from our 0, 0. So if I look at this one, I ended up going left 3. Okay, left 3 would be a positive 3. For my K, it's how many I go up or down. So I went down 2 to get to the vertex. So that means my K would be a negative 2. Okay, so for this one then, when you write the function out, okay, you'd have a 1 there, which we don't technically have to write. It'd be an x plus 3 squared and a minus 2. Okay, so again, works the same way. You always want to find that vertex to determine your H and K, and then the A you can determine like I talked about previously. Okay, for B, okay, you have a graph that looks something like this. Okay, again, still want to find the A, the H, and the K. Okay, so for this one's going down, which means my A will be negative. Again, if you go over 1, you'll notice it only goes down 1. So that tells me my A is going to be negative 1. For my H, this one goes right 2. Okay, if it goes right 2, that would be a negative 2. And then you'll notice it is up 4 to the vertex. So that means my K would be a positive 4. So when we write this one, we'll get y equals negative. You can put a 1 there if you want to. X squared minus 2 squared plus 4. Okay, for that one. All right, so again, just kind of another way to get it is from the graph itself. But always looking for the A, the H, and the K. That's the important pieces that we need to find. And the last type of examples we have here then are graphing them with the transformations. Now I know we've been doing quite a bit of this where you put it in the calculator, and you can check in the calculator, but I want to show you how we can also do it without the calculator. Okay, the calculator is not necessary when we know our transformations. Okay, so the first one you guys have is y equals negative 2, the x minus 3 squared plus 4. Okay, you always want to graph the vertex first. So the vertex I get from my h and my k. Okay, and it's also the first thing that it asks you to find as well. Okay, so if this is a negative 3, that means I'm going right 3. And if this is a positive 4, that means I'm going up 4. Okay, so that means my vertex is at 3, 4. Axis of symmetry, remember, always lines up with the x because it's a vertical line. So my axis of symmetry will be x equals 3 because that's what the vertex, x part of the vertex is. Okay, so then we want our domain and our range. It also asks us to find, and we'll also finish graphing this in a second. Okay, domain we know is always going to be all real numbers no matter what. And range, you'll notice this graph, we probably want to finish graphing it before we find the range. It's a negative 2. So that means when I go over 1, I want to go down 2. And then I want to mirror it on the other side. If I go over 1, I need to go down 2. So my graph is going to end up looking like this based off the transformation. You'll notice the graph is going down. Range is always y values. Always, always, always. Since I'm going down, it would be a less than or equal to. And then the y value is 4 that I'm going down from. So again, didn't even have to put it in the calculator. Again, you're more than welcome to check them in the calculator. I have no problem with that. I would like you to first try them, though, without the calculator, just so you can make sure you know how all the transformations work. Okay, one more of these then. So for this one, y equals 1/2 x plus 4, 5. Okay, so again, always do the vertex first. In this case, it's telling me to go left 4 and down 5. Okay, so that means that my vertex will be at negative 4, negative 5. Okay, that means my axis of symmetry has to be x equals negative 4. Again, always matches up with the x. Okay, my domain is always all real numbers, so I don't have to worry about changing that. And again, we don't want to get the range until we finish graphing it. Okay, this one is a positive 1/2 for the a. So that means when I go over 1, I'm only going to go up 1/2. Same on the other side, I go over 1, I only go up 1/2. So this one ends up being wider, which is exactly what we would expect with the 1/2. Since this one's going up, our range is going to be y is greater than or equal to, this time, negative 5, because that's the lowest point, and then we're going up from there. All right? So this is going to wrap up the vertex form then. Okay, so you have your worksheet. Make sure you guys get that worksheet. I did give you the answer key as well, so you can check your answers. And then you got a few problems on the Google assignment that you'll want to finish as well. Okay, tomorrow we're going to look at 9.2, which is another way we can graph if it's in standard form. Okay, up to this point we've only been in vertex form, but we're going to end up changing it to standard form tomorrow. All right, have a great day.